Okay, the today topic, which is the continuation of our previous session, the gate questions. Okay, it's very helpful for you for your IIT too. So one is over, and the part two is also over, three over, and this is the fourth. Okay, which one of the following is true? Who is the person? I'm asking you people. Kindly post in the chat box. I'm taking the notes of the student name who are all interacting. I will put today date. What about the first language, which is regular? D. Which one of the following is true? From Gayatri, which is A. Actually, A power n, B power n. Could you able to draw finite automata for this language? Try to interpret this. Could you able to, if it is regular means it is probable to draw a finite automata for this language. Then only that language is coming to the part of regular, right? So all regular languages are accepted by automata. We can draw for first A power n, B power n. Which means how many number of A, how many times the A is repeated, the same time B is also repeated, right? Which one of 40? T means W, only 2W. That W either belongs to 0 or 1. Okay, 0 or 1. So is it coming to the regular? Regular means what? The strings which is very limited. Okay. Actually, D, which is the confusion state here. Okay, that is why they have added D, which is in your option. Kausika, okay. Because this is a decade question, some answers are exactly which is you can put in the category of not in the answer. Okay, the first A, which is actually definitely this is not regular A, and the second one, which is also definitely regular, which is not regular because first A and B both are having both needs to have some some memory, additional memory. Okay, and D, which is in the confusion state. Okay, so what about C? C actually, this is the question which we have already had in the unit 1. That is 3k plus 1. 3k plus 1, where k is the natural number. So 3k means a multiple of 3, right? So multiple of 3 plus 1. So you can draw automata for multiple of 3. This is the repeated university question. Multiple of 3, multiple of 2, multiple of 4. Okay. So D, actually D, which is in the confusion state, you can put some percentage, 80 percentage, right? Okay. You can put some percentage. Okay. Exactly, you can draw. Actually, this is the question which is available. C. So let me check the answer. Actually, C is the right one. Okay. Who are marking C, Kausika and Swati, Nandini. Okay, all right. See the explanation. So A power n, B power n means so for every number of, you can easily draw a context push-down automata, right? How many number of A is repeated, that B is also repeated. So A is in the position of a push. While reading A, you are push A into the stack. While reading B, you are popped A from the stack. So that's the concept. A power n, which is also have some memory prime. Okay. Actually, this is what comes under context sensitive language. Actually, in this prime number, we can't aware of where to push and where to pop. We're completely unaware of that situation. That situation is considered context sensitive grammar. Okay, so this second language which is considered context sensitive, and the third multiple of 3 plus 1. Okay, actually the language, the problem statement of third, which is multiple of 3 plus 1, you can draw DFA and see here the last part WW. Actually, this part which is also comes under context sensitive language, because the context sensitive language is not a part of your syllabus. That is why we are completely unaware of context sensitive language. Mm, context sensitive language in context free language means if you are considered the last one, which is context free, means we are not know how where to push and where to pop. Okay. Um, So this is the part of context sensitive. So almost the third, which is the right one. Okay. See, very important gate question. See here, the fifth one. Kindly post your answer along with your question number. It's putting me into the dilemma state. First, understand the concept from the diagram. What this piston, what's the process happening over on the piston automata? The functionality of piston automata. What will happen when you are reading 0 or when you are reading 1? What will happen? Okay, first you can understand the ideology of the piston automata behind. You can easily find the strings. They have given one string as input, right? 101100. First, you will check whether this string is acceptable over on the piston automata or not. What's the logic behind? First, you have to identify the logic behind this piston automata. So I'll explain the logic. Here, if you are reading the input symbol from the page, which is 0, means 0 is pushed onto the stack along with the type symbol Z. Okay. If you are reading the input symbol from the page, which is 1, means you are pushed onto the stack 1. Okay. So this was happened in the Q0 state. Okay. From Q0, Q1 will move to Q1 when the situation is, it may be either coming input, it may be either 0 or 1 or no other input without reading input. Okay. This means what? Z as, tends to as it is. Actually, there is no any change. Okay, there is no any change in the current stack. That is why the push the push symbol as well as the pop symbol both are same. Which means if the pushed symbol as well as the popped data both are same, means there is no any change currently made over on the stack. So in the Q1 state, when you are reading 0, okay, when you are reading 0, if the top of the stack, if it is 1, means the 1 is popped. Okay. So in the Q1 state, if you are reading 0, that is current input, which is 0, means 1 is popped. If the current input, which is 1, means 0 is popped. Okay. So see, if the string 1 0 0 1. Okay. See, for the first one, Q1 state, one is pushed. One is pushed over on the stack. Okay, actually the stack contains Z naught. Then next 0, again the 0 is pushed. See, in the third part, without reading input, it moves to Q1. And if it is 0, okay, if it is reading 0, actually 1 is pushed, 0 is pushed. Okay. Actually, this is the reverse part. Sorry, I have made the string as which is wrong. It is what is confusion state. 1 0. Actually, that's the reverse part of the string. That is, if it is 0 means this is 1. If it is 1 means this is 0. In between there is no any string. Okay, so these strings are pushed onto the stack. If the incoming string from the tape which is 1 means 0 is popped. See, if 1 means 0 is popped, okay, the top of the symbol 0 here which is popped. Okay. If then if the current reading input, if it is 0 means, okay, if 0 means what, 0 current input which is 0 means, okay, what's the top of that stack? 1. 1 is popped. Okay, so actually the string is, see, coming to this string 1 0 1 1 0. So for this is the Q naught state. Okay, pushed state. While reading this 2 1 0, these two inputs are pushed onto your state. And while reading this one, you are automata moving to the state from Q0 to Q1. See here, on reading 1, there is no any change. Okay, leave it. This is the part for Q1, that is push pop. Okay, if 1 is reading, that 0 is popped. If 0 is reading, that 1 is popped. Okay, so this is okay. Second one, 1 double 0 1 0. See here, while reading the in between 0, there is no any change. This is push, this is pop. If 0 is top of the stack, if 1 is reading means for 1 is coming, 0 is top of the stack, 1 is coming, 0 is top of the stack, 0 is popped. If 0 is coming, 1 is pop of the stack, that 1 is popped. Okay, so this is also okay. But they have given one string as input 101100, but this is not possible. Okay, 0, but because these two are same. Okay, um, and see here the last one 01001. Okay, this is in between, there is no any change. This is push, this is pop. If you if current, this is also actually acceptable, but they are giving one string as input. Based on the string 10110, which is the right one. Okay, actually 3 strings are acceptable from this automata, but based on the input string they are given, you will pick A, which is the right one. Okay, so this is the logic. So this is the logic. As per the logic, actually these are all the forms of inputs that have accepted by this push-down automata. That is, what's the forms of input? In between, either it may be 0, in between, either it may be 1, but in between there is no any string. If X is means after the 0 or 1 are no symbol, the reverse which is available. Okay. If X means 1, X reverse. Yeah, X reverse. Okay, so 1, 0. If 1 means 0, 0, 1. If 0 means 1. If 0, 0, 0 means 1. And if 1 means 0. If 0 means 1. So these are all strings which is acceptable by this push-down automata. Okay. Is it clear? B is the right one, Sanjay. Based on the given input string, Actually, there are three strings which are those are acceptable by this automata, but they have given one string as input, right? So more than one symbols, more than one are acceptable by this automata, but they have given this input. Okay. So based on this string 10110, see which one of the following sequences must follow the string 101100 so that the overall string is accepted by the automata. So 10110. This is the right one. Okay. Actually, ah, so-
Include 10110 at the end of 101100. The this automata won't work. Like
please
it
repeat,
satisfies
repeat the string. Please repeat the string.
101100.
101100. Okay.
Then if you put a option A, ma'am, along with it, ma'am, 101100, 10110.
This is the option. Yes.
This won't be satisfied, ma'am. But whereas when it comes to B, it satisfies the automata, so that the automata gets terminated.
Ah, yes. B also acceptable by this push-run automata. B also acceptable one.
Ma'am, but in the question they are asking, what must follow the sequence in order to get accepted by the automata?
Based on this string, I will pick A, which is the right one.
No, ma'am. When you go back, it won't satisfy, ma'am. Like you have to try this one, ma'am.
Which one?
Just I mean, how to say this, ma'am? Just append the string with the previous one, ma'am. I'll tell you what it is. 101100 101100
101100.
10110.
This is the overall string,
Yes,
right?
ma'am. Then try applying this into the automata, ma'am.
Oh, okay, wait, wait.
It won't get satisfied. Whereas when it comes to option B, it
11. See
satisfied.
here, this is 11. Okay, this is the middle element, right? This is the middle one. So here 5, here also 5. As 0, 1 will come, okay. For 1, 0 will come. For this one, 0, 1, 1, 0, 0.
See, ma'am, it won't
Yes,
get satisfied, ma'am.
yes. This one, actually 1 will come. This one for 0 will, yes. One string, this one state which is wrong, right?
Yes, ma'am.
Okay, I will try it the
Whereas
next
when
one.
you apply option B, it will get satisfied, ma'am.
One double zero, that is 1 0. Yes, okay. 11. So this is the middle element. So 5, this is 5. For 0, 1 will come. For 1, 0 will come. For 1, 0 will come. For 0, 1 will come. For 1, 0 will come. Yes, actually this is the right one. B is the right one. But in your, actually in your YouTube, sorry, in your, I have taken from this one from, that is gate overflow, I think. Gate overflow are Greeks. So they will pick option A, which is the right one. Okay. But option B, which is the right. Thank you, Sanjay. You're excellent. Okay, students, is it clear? D is the right one. Okay. Is it clear? Nandini, then Swati, Ujwala, some Kausika, Godson. Okay. So which one of the following sequences must follow the string? Okay, must follow the string so that the overall string is accepted by automata means we have to write 1011 2 0, which is the string, which is followed by next string 1 0 1 1 0. You have to take in the second one. So then you have to take in the B part. So third part. So B part. So you have to apply the logic. Okay. So find the logic. If you are able to find the logic, means then you can able to find the string. Okay. So B is the right one. Next. Okay. Which of the following languages are context free? See, in gate question, context free means only one stack can be able to um, accept such kind of languages, such kind of strings. If more than one stack, if you want some more than one stack means definitely there is not a context free. One stack, okay? This is one tips from gate question POC. So please post the answer along with the question number. So Sanjay Charan, you are picking D for 6, right? Okay. What about others? L3. Yes, L3, which is the context free. Because A power m, B power n. So m equal to 2n plus 1, right? So for 2 A, 1 B is popped. Okay. For single B, 2A is popped. The logic, can find the logic. Okay. So what about L1 and L2? Try to figure out L1 and L2. Which one is regular, Rakesh? Which one needs both L1 and L2, which needs 2 stacks? What about L1? Or L1 need 1 stack or 2 stack? See, in L1, it was somewhat related with the previous logic. See, uh, B power n, A power n. Okay, in between. So in between B power n, A power n. So here A power n, B power n. There was some relations, right? A power n, B power n, B power n, A power n. So which one is the push part? The first two, A power n, B power n. This is the push part, right? How many number of A you are reading? That number of B which is popped, right? How many number of B you are reading? That number of A which is popped, right? If A is 2 times, B is 1 time, A is 1 time because B is 1 time. Here B is 2 time, since B is 2 time because A is 2 time. Okay, I will say this is the push part AAB. So push part, first A which is pushed, second A which is pushed, third B which is pushed. While reading 1A, I popped 1B. While reading 1B, I popped 1A. While reading next B, I popped 1A. Without reading, we can pop the initialized state symbol, stack symbol, is it not? So this is also context free. One stack is enough. But here it is not possible. So B is the right one. L1 and L3. Okay, clear? Is it clear or not? See the explanation. Is it clear or not? Okay, I will move next one. This is one easiest one, and anyone can try to this seventh one. That substitution, which is enough. Okay, very easiest part. Question automata means we have to know some logic. We have to know some functionality of question automata. So this question almost everyone could answer it and write it in your note. Put a separate note for TOC, which is the must. Pick the answer A, B, C, D and work on the grammar part. Okay, I will see the answer. So the last not generated because first three are generated by this grammar. D which is not generated. Okay, so they are just explanation. This is derived. This is derived. C is also derived, but D which can't be derived. Then the last question because I have to start the Turing machine part from today. So closure properties of regular language as well as closure properties of context-free language both are very important to crackle your quiz. Okay. Which of the following are correct? True, right? L1, L2 be any two context-free languages or which is irregular. Why people are left the meeting? Harshita. So union of L1 and L2. So yeah, yes, context. So according to the closure property of CFL, context-free languages, a context-free languages are closed under union, right? One is the right. To complement the third one, see L1 minus R is context free. See L1 is the context free, R is the regular. Okay. So if you are removing R part means the remaining part which is context free, which is also true. Intersection, the last part. Sanjay, A part which includes the last one, fourth part. L1 intersection L2 is context free. But recall the closure property of context free, intersection or context free languages are closed under intersection? No, I think. Let me check the answer. Nandini, you are picking B. Ujwala picking B. Let me check. B is the right one. Okay. This is definitely not a context free because intersection. Okay. 1 and 3. 1 and 3. As see intersection as well as complement both are related. If a language is not closed under intersection means that language is definitely not closed under complement. Both are interrelated. Okay, 1 and 3. B is the right one. Okay. So the almost the great question part which is over. Okay. Next, some introduction about Turing machine. The important one. Some few people are left from the meeting. I don't know why. The important thing which will start. So just I will give you a few lines on introduction. a Turing machine. Okay, an important thing in your TOC concept, a Turing machine. Um, we have already seen two types of machines. They are very basic machine, which is a finite automata, very basic abstract machine. The second machine, which is Christian automata, and the third machine, Turing machine. Okay, which is for the languages, recursive enumerable languages. Okay, actually type three, right? Christian automata for type two. So type three, a Turing machine, which is for recursive enumerable languages. I will tell you later what do you mean by recursive enumerable languages. So this topic, which is about not technical term, which is about Alan Turing. Okay, so Alan Turing uh, was the inventor of Turing machine. Okay, so this is the Alan Turing. So while Charles Babbage, you have already known that name, Charles Babbage and Ada Lovelace, the first computer programmer, who is Ada, uh, can be considered the parents of computers and programming. Alan Turing is often called the father of computer science. Okay, very suitable person. During the Second World War, Turing worked on cracking the encrypted messages used by the German armed force. Okay, actually, the machine he invented a machine that machine name is Enigma. Okay, you can Google on it. Just Enigma machine used to crack the encrypted messages, which was used by some German forces. Um, so he can found the machine Enigma. So when Alan Turing working on a mathematical problem concerning decidability and the halting problem, see decidability, the halting problem, these terms are very familiar in Unit 5. Okay, while working on this problem, he realized to design a mathematical description of a machine. Okay, he wants to design a machine could solve some problems. Okay, Turing machine which is based on some algorithms. Okay, so these machines came to known as Turing machine. Um, First, how to work. So this is Alan Turing. This is the definition of a Turing machine. Okay, he has designed this Turing machine in 1936, 37. Uh, it was to help investigate the extent and limitations of what can be computed, right? Okay, what can be computed, what cannot be computed. That is the decidability of a problem. Okay, so can be investigated using the Turing machines. He named as automatic machines. Okay, but Alonzo Church. Okay, actually, Alan Turing, released a thesis work, that is a Turing paper. Okay, based on this paper, Alonzo Church, who named this machine as Turing machine. Okay, but Turing, which is named as automatic machine. So nowadays, which is the very basic for the foundational model of computability and computer science. In your next semester, you will have your own paper, artificial intelligence. In the first unit, you will have the Turing test, one of the topic, which was introduced by Turing. Okay, he is also a father of artificial intelligence. Okay. Um, Next, this is the working procedure. Actually, a Turing machine consists of a infinitely long tape. Okay, this is the tape. The tape which has some cells divided into cells. The tape is infinite, and the tape is divided into cells. Each cells can contain either one or zero or empty spaces. Okay, either one or zero or either A or B or some empty spaces. Empty spaces which is also filled with one symbol, that is blank symbol. This tape, particularly this tape has one head which can either move left or right. Okay, not only this tape, almost the Turing machine tape which has one head which can either move left or right. One cell can read the symbol. Okay, can read the symbols written over on the cell. The head is also capable of erasing symbols and writing a new symbol into the cells. See, from this demo you can easily verifying it. It is some erasing a symbol and writing a new symbol over on the cell. Actually, one Hollywood movie which was released in 2014 about Alan Turing. Okay, the movie name is The Imitation Game. Okay, uh, so Alan Turing proved that any problem that is computable, see, any problem that is computable, can be computed by Turing machine using this simple algorithm. Here, this is one of the Turing machine, simple Turing machine, and the square bracket, the table, which is the algorithm. Okay, algorithm for this machine. See, in this machine, if any blank symbol over on the tape, which means don't need to write anything, and there is move also none. If you are reading zero means, okay, you have to write one instead of zero and move left. If you are reading one means you have to write zero and move left. This is simple logic. Okay, so Turing machine, which is purely based on the algorithms or instructions you have given to the machine. Okay, so these are some intro about Turing machine. So this is some that as usual technical part. I will start the technical Turing machine part uh, from the next day session. Okay, next week. That is like Pushton automata, compare with finite state machine, compare with the Pushton automata, Turing machine. Okay, and tuples. Definition means as per your theory of computation topic, a definition which is nothing but the tuples. How many tuples in finite state machine? Kindly post in the chat box. How many tuples in the finite state machine? 5, yes. How many tuples in the Pushton automata? Yes, the same way. Turing machine also having symbols like 7. Okay, 7 tuples. So 5 tuples for finite state machine, 5 tuples for Pushton automata, and 7 tuples for Pushton automata as well as 7 tuples for Turing machine. Okay. In Pushton automata, you will have like tape, sorry, it is stack, the stack symbols. Is it not like that, right? But here, blank symbol, tape symbol. We will call tape symbol, blank symbol. Okay, tape symbol, which is the combination of terminals. That is, it may be 0 or 1 as well as the blank symbol. Okay, the blank symbol in POC, which is used to in Turing machine, which is used to fill the empty cells. Okay, so operations over on the tape, which is starts with the tape head, read or scan the symbol below the tape head. Okay, here this is the tape head. Read or scan the symbol. So update or write a symbol below the tape head. Okay, you can update or write anything. Move the tape symbol one step left. Okay, or right. Okay, you can move one step left or right. Okay, so at each step of the computation, so read the current symbol, update, and move exactly one symbol left or right. This is the very simple basic operations over on the tape. Okay, that is the operations, the computations on the tape, which is just read the current symbol, just update it. Update means write it. Okay, you can update or you can leave it. Both are possible. You can update or update means you can if it is zero means you can update it one, or else no any operations like Pushton automata without reading symbol you can move. Okay, without updating you can move. So move exactly one symbol either left or right. Okay, these are the three basic operations over on the tape. Read the current symbol, update the cell, then move exactly one cell either left or right. Okay, so the technical part, which will start from the next day session. Then we will see one problem. Okay, during problems. Thank you, students. Is there any query? This is the clarification part. Is there any query? Please ask me in the chat box or unmute your mic and ask.